Hello everyone, so let's start the heat transfer course and I hope you're as excited as I am. I'm starting at a very high level and then we're gonna quickly go into the details. So I just want to say that whenever a temperature difference exists in a medium or between two different things, then heat transfer must occur. And over here you see a picture of a hot coffee in a room. So let's say the room is at room temperature, it's ambient, let's say it's at 20 degrees Celsius, and you have the cup of coffee which is hot. So the cup of coffee could be at 40, 50, 60 degrees Celsius. And what do you think happens when you put that coffee in the cold room? The coffee will eventually, the temperature of the coffee will start going down with time until it reaches the room temperature. And at that point, when the coffee temperature reaches the same temperature as the room temperature, we call that point thermal equilibrium. So that is the first thing I want you to know, which is the definition of thermal equilibrium. So when you have two things that are in close proximity to each other and their temperatures match and their temperatures become the same, that means that they are in thermal equilibrium with each other, and that means there's no transfer of heat between these two objects. So when studying thermodynamics, the question becomes, what is the final temperature that the coffee will eventually reach? However, when you study heat transfer, the question is different. The question becomes, how fast will it cool? Or what can we do? How can we manipulate this situation so that we could increase the heat transfer or that we could reduce the heat transfer? Because as you know, if you want the coffee to stay hot for as long as possible, you could put insulation in the cup. And so you could get a different kind of cup to drink in. So these are options that you can do to manipulate the heat transfer rate and slow down the cooling of the coffee cup, because nobody wants to have a cold cup of coffee. So while thermodynamics is used to determine the amount of energy required in the form of heat for a system to eventually pass from one state to another, it doesn't consider the mechanism that provides that heat exchange, and it doesn't give you the equations that you need to compute that rate of heat exchange. However, this heat transfer course specifically seeks to quantify these rate equations so that eventually you can size heat exchangers and unit operations that involve heat transfer.